All right, let's talk about U substitution. Um, Generally, we can use the skill of U substitution to find integrals. But there are some rules, actually conditions that we can use U substitution. Number one, there are two conditions to use U substitution as a skill to find integral. Number one, there are two functions. In given equation, there are two functions. And if you can find derivative related expressions between two functions, we can use U substitution. Number two, if there is linear expression or linear functions to the n power form, we can use U substitution. Let's talk about these two cases in more detail by using examples. Number one, look at this example. There are two functions, two polynomial functions. First one is x cubed plus 2x minus 3. Second one is 6x squared plus 4. I think this is first case. Two functions, and we can find derivative related expressions between them. In these two functions, which one is greater? X to the third power plus 2x minus 3 is greater. So x to the third power plus 2x minus 3. Let's find its derivative in terms of x. It's going to be 3x squared plus 2, right? Derivative of first expression is closely related to the second expression, because derivative of first one times 2 is the second expression given. In this case, we can say that there is derivative related expressions between these two. So we can use U substitution. For this case, we can substitute U for the original bigger function, x cubed plus 2x minus 3. And then you differentiate both sides. Left side, differentiate left side in terms of x, and differentiate right side in terms of u. So left side should be 3x squared plus 2 times dx. The other side, derivative of u in terms of u, 1 du. And the next step is important. You are isolating dx. So dx is equal to du, 1 du is du, over 3x squared plus 2. And then you rewrite this given equation, this given integral expression to another integral expression in terms of u. So first polynomial function is already substituted by u. So for that expression, you just use u. But second function, 6x squared plus 4, 6x squared plus 4 is not replaced. Just keep it. And for dx, you can replace dx with du over 3x squared plus 2. So du over 3x squared plus 2, like this. After you substitute u for first function, you should rewrite the given integral expression in terms of u, like this, and then simplify. That one is twice of this, right? So cancel, 2. So this integral is changed to integral 2 times u, 2u du. You can take out 2 times integral u du. So now you can the easy way, which is power rule of integration. 2 times 1 over 1 plus 1 times u to the 1 plus 1 power plus c. This is 2, cancel out. Coefficient is 1, so the answer is u squared plus c. But the original question is in terms of c. So as a last step, you have to go back to the original expression in terms of x. U means 3x cubed plus 2x minus 3. So parenthesis x to the third power plus 2x minus 3 to the second power plus c. This is answer. Let's try one more question. Yeah. Integral t minus 1 over square root of t squared minus 2t dt. Yep. In this question, we can also find derivative-related expressions between these two, t minus 1 and t squared minus 2t. T square root doesn't matter. You can just try to find the relationship between any two expressions possible in terms of derivative. So let's find the derivative of t squared minus 2t in terms of t. Derivative of t squared minus 2t is 2t minus 2, which is twice of numerator. Coefficient doesn't matter. They are related. Therefore, we can use substitution. All right. Now, we're going to substitute u for t squared minus 2t, which is the original function, and then differentiate both sides in terms of t and in terms of u. Left side is 2t minus 2 dt. Right side is du. And then you isolate dt. So dt is du over 2t minus 2. I'm going to factor 2 out like this way. And then rewrite this equation, the original integration expression in terms of u. You have to change the original one to another expression in terms of u. That's why we are using u substitution. So numerator t minus 1 is not changed. Denominator square root of t squared minus 2t, that one is replaced by u. And then dt means du over 2 times parenthesis t minus 1. And then you cancel out the common factors. So we can change this to the original one to 1 over square root of u du form. Much simpler, right? Which means u to the negative 1/2 power du. Now we can use power rule of integration. So 1 over negative 1/2 plus 1 times u to the negative 1/2 power plus negative 1/2 plus 1 power plus c. Denominator is 1/2. 1 over 1/2 is 2 times u to the negative 1/2 plus 1, which is 1/2 power plus c. Oh, there is 1/2 here. I forgot. Sorry, 1/2. So 1/2. Yeah. There should be 1/2 in the front. 1/2 times 2. Sorry. So 2 and 1/2 canceled out. So the answer is square root of u plus c. Finally, you go back to the original expression in terms of t. So for u, you plug in t squared minus 2t plus c. This is answer. Okay, let's try one more question. Sin x, integral sin x times e to the cosine x power. Yeah, I think we can find the derivative related expressions between sin x and cosine x. In this case, you better substitute u for cosine x. Okay, and then you differentiate both sides. The left side in terms of x, right side in terms of u. Derivative of cosine x is negative sin x. dx. Derivative of u is 1 du. Next step is to isolate dx, which is du over negative sine x. And then you rewrite this, the original integral expression. So sine x, you keep sine x, and e to the cosine x power. Cosine x is already substituted by u. So you put u, dx is du over negative sine x. And then you cancel out sine x in numerator, sine x in denominator. So it's going to be negative integral e to the u power d. What is antiderivative of e to the u power in terms of u? Same, right? E to the u power plus c. Finally, go back to the original expression in terms of x. U means cosine x. So you plug in cosine x for u plus c. Don't forget to add the c. This is indefinite integration. Next example is for the second case. I said we can use substitution in these two cases. Number one, if there are derivative related expressions between two functions, we can use u sub. Second case is linear to the n powerful. Linear to the n powerful. Next example is for second case, linear to the n powerful. All right, in example 6, there is a linear expression to the n powerful. Right, linear to the n powerful. So we can use u substitution. In this case, you just use u for the given linear expression. So 7x minus 5 is equal to u. The rest of the steps are same. You differentiate left side in terms of x and right side in terms of u. So left side is 7 dx, right side is du. So dx, if you isolate dx, it's going to be du over 7. And then you rewrite the original integral. Integral u to the 5th power, dx means du over 7. So it's going to be 1/7 integral u to the 5th power du. Now you can use power law of integration. 1 over the original exponent 5 plus 1 times u to the original exponent 5 plus 1 power plus c. So 1 over 7 times 1 over 6, which is 1 over 42, u to the 6th power c. As a final step, you go back to the original. U means 7x minus 5. So parenthesis 7x minus 5 to the 6th power plus c. Okay, that's the answer. Let's try one more question. Number 7, integral 3 over square root of 1 minus parenthesis 5x squared. Oh, there is linear to the n powerful, right? Linear to the n powerful. So I'm going to substitute u for linear expression itself. 5x equals u. Differentiate. 5 dx equals du over 5 dx equals du, and dx is equal to du over 5. All right, and then you rewrite this expression in integral 3 over square root of 1 minus 5x is substituted by u. So we're going to use u and then make it squared. Dx means du over 5. I can take out 3 over 5 in the front. So 3 over 5 integral 1 over square root of 1 minus u squared du. You are very familiar with this, right? That one is antiderivative of sine inverse, right? Sine inverse. So the answer is 3 over 5 sine inverse u plus c, which means 3 over 5 sine inverse u. U means 5x. Go back to the original expression in terms of x. So the answer is 3 over 5 arc sine or sine inverse 5x plus c.